here is the syntax. Now tapply, note what we got back when we ran that. We did not get a list back. We just simply got a named vector. That's what this is. It's a named vector. It's got 4 values with names. And a vector is a one-dimensional array. And the length of it is the number of unique values in the levels. Now, this apply function, each of the apply functions do some do similar things, but many of them don't. So learning them takes time. There are groups of apply functions that go together that are similar. tapply, lapply, and sapply are related. They're cousins. But they operate on both data frames and lists, but they're different from the other ones. Okay, so let's do it again. So here we run it one more time, and we want to round these values down. Well, we can do that. We can just use round, embed this entire expression into round, and say we just want to have 1 digit. That's the beauty of R. It's Lisp-like. So you can, whatever expression you can dream of, you can always make it more complex, or said a different way, you can make your life easier, because whatever expression you have, you can always use that in an argument to a more complex expression. So you don't have to write line after line after line after line of code. You can put everything in one single line. Now, it's going to get very difficult to remember what all of the arguments do, but you have that power. Okay, what else can we do with apply? Let's say we wanted the average. Okay, so let's extend this example with tapply. Say we wanted the average. Note with tapply, you can have a list of categorical variables, not just one. So in this case, it will find the unique number of levels of plot, the unique numbers of levels of species, and return this for both. Here are the plots. Here are the species. You could have 3. If you use 3, then you're going to get an array back that's going to have 3 dimensions, because you can't have, plot, species. You run out of table dimensions. Okay, so what do we do here? Here we take tapply for the same expression up above, and we assign it to this variable HTTPS, and now we're going to round it. Makes it look better. Note, however, we get these NAs. It doesn't die. Mean does not like missing data. So there's no combination. There's no numbers in the combination of plot2 and species WC. There's nothing, there aren't any values there. So rather than fail, it just prints out all of the possible combinations of the levels of these 2 categorical variables, and if there are no numbers, it puts NA. So it's very fault tolerant. Okay, what else can we do? lapply and sapply, these 2 functions, these 2 apply functions are kissing cousins. They do the exact same thing. That is, they will they will perform a single function on vectors. In the case of lapply, it only works on a list. That is, the vectors must be in a list, and it only returns a list. So lapply, that one's easy to remember because of the L. It's like table apply, but it works on lists and returns the list. sapply also works on lists or data frames by extension, but it will try to simplify the output. It will try to return the output as a vector if it can. Otherwise, it returns it as a list, just like this one. Let's look at an example. Here's the syntax for both of them. It's simpler. So X is the data set, function's the function. Triple dot enables you to put to move arguments here. X is a list. It's a list of vectors. And let's take a look. So here we're going to use the tree data some more. And let's look at the head of this data set because it's quite easy, to forget. So we have plot. This is categorical. These are counts, I believe, if I'm not mistaken. No, this is categorical as well. These are tree is a type of tree. Species. This is categorical. This is numeric. This is numeric. We're going to on the fly, we're going to do a calculation and add that computed value as a column. The column name is this. Okay, so let's do that. So if we say here's the head, this is what it looks like now. If we run this line, then take a look, we see that a sixth column has been added, which for each row makes this calculation. It's the volume. So what has it done? It said pi times the diameter breast height divided by 200 squared times the 200, I guess, is the centimeters above the ground at that level, perhaps. Anyway, it's computing volume. And lapply will return this as a list. So with lapply, let's try this. We're going to run lapply against the third, fourth, and fifth columns. I'm sorry, the fourth, fifth, and sixth columns. Takes the mean, so it's just returning simply the mean of each of these three columns. Look at the head of UFC again. It looks like this. Tree data. The fourth, the fifth, and the sixth column are numeric. So you can run lapply. Remember, we said it works on a vector or on a list. These are three vectors. And it returns them as a list. lapply always returns a list. sapply does the same thing, but it'll smash it down to a vector. So same argument, function does the same thing, but it expresses it in the simplest possible way, which in this case is a named vector. Okay, so sapply, if you want simple output, the simplest output, sapply is better, is preferred to lapply. Okay, here's one more. This is a simpler version. This is a vectorized approach to extract the name of the winner, the premiership winner, from our list, our premierships list that we created in the previous example. And note, sapply, these functions are often described as vectorized. They're vectorized functions. What does that mean? Well, it doesn't really mean that they do something against each element of a vector, although they do. What it really tries to connote is that they work on complex structures. They'll work on lists, they'll work on arrays in some cases, which can have more than 2 dimensions. And they will run whatever function you're interested in running piece by piece. And they'll figure out how to break it down. Okay, so they're called vectorized, and they're designed to be fast. They are. They replace for loops. You don't need to write for loops. You can use these. These will do it for you. And they're faster. So here we create a function. It's only a one-liner. It says return whichever element of X has 1967. So that's the function. And then we call it, we just simply call the function here. We say sapply, it will apply it to each component. And there's only one component that has the name, which is the name of the component that won the premiership in that year. So we get Richmond. We can use sapply to calculate the number of premierships won by each team. Normally, if you run length against a list, it returns the number of components. If you combine length with sapply, then it counts the number of elements in the component. So this will return the names sorted by the number of premierships that they won. This Fremantle, unlucky, never won any. Essendon has won the most. Or you can, if you wanted to subset the list of premierships such that they were just post a certain year, as in this case, X greater than 1990. So we create a function. Note I've enclosed this function in brackets, and the purpose of that, if you express a function like this in brackets, it will also return the results. If I do it without the brackets, the line still executes, but you don't know what's going on. Now, in this case, nothing is going on. All we get is the function itself. But if the function returns a value when it's called, and we're not calling it, we're defining it in this statement, then it will, when you embed the function call in brackets, but this serves to show us what it looks like. Here, on the other hand, this will execute this, we'll assign it to premierships, but it'll show us the result. So let's do that. So there are the premierships, teams that won premierships post 1990 or post 1989. Melbourne didn't win any. It returns every name and it shows you the years if they're greater than 1990. This one's empty, this one's empty, this one's empty. What else can we do? We could do this is that's what we just did. We could say show me the structure. So here's the structure. It's headed up by, it's a list of 16, and there are these numerics of the years that they won. Here's another function between years where if we want to know the number of premierships won by a team in some interval. So we're defining the function here between years where it takes the list that has the data and then the lower bound of the time interval, the upper bound. And note what it does, it just takes this in the body and just simply has a complex conditional statement. This just returns true or false. Okay, so A must be less than or equal to X, and X must be less than or equal to B. It ignores all the other ones. So it will only consider teams that had something in between these 2 years. Otherwise, it ignores them. Okay, so we load up that function, and let's make this smaller so we can see it. So you get a sense now what you can do with a list. You can make an extremely complex list and then create your own user-defined functions. And we want to know now which one's won between 70 and 79. So we're going to call our function with lapply, which always returns a list. And the ones that have 0, of course, didn't win between 70 and 79. The other ones did.